Hello, my name is James Coley, and today we'll be talking about mapping changes in urban sprawl in the greater Orlando area from 2000 through 2025. As an introduction, the state of Florida has experienced rapid growth in land use changes since the year 2000. The population has grown from 16 million in 2000 to 23.5 million in 2025. Population growth leads to urban growth, which reshapes land, infrastructure, and ecosystems. The goal of this research project is to look at how much did urban areas change between 2000, 2010, 2020, and 2025. When and where did this urban growth take place? And how is it affecting the future? Finally, a land use classification will be done via a random forest model, since the area would be much too large to do this by hand. The greater Orlando area, as I'm defining it, is Orange, Seminole, and northern Osceola counties, and western Lake counties. This is a slightly smaller area than the Orlando-Kissimmee MSA, which contains the complete Osceola and complete Lake counties. The study area was built from the four county geometries, but with Osceola and Lake counties were cut in half by their midpoints, so being bisected north to south or east to west. For data sources, the Landsat surface reflectance at 30-meter resolution was used. Landsat 5.7 for years 20,000 and 2010. And Landsat 8.9 for 2020 and 2025. Annual data was then cloud masked and median composites were used. Landsat makes for easy comparison across decades since it is consistent at the 30-meter resolution. Spectral bands that were collected were blue, green, red, near infrared, swirl 1, and swirl 2. Calculated bands used were ND-VI, ND-WI, and ND-BI. Data was pre-processed to help clear up images. Cloud shadows and saturation were masked via QA methods, and sensor harmonization was used to create a common band. Finally, annual median composites were used to get consistency across time. Next step was classification. The random forest classifier was used all of our measured bands, the blue, green, red, near, swirl 1, and swirl 2s, and our three composites, ND-VI, ND-WI, and ND-BI. The model was then trained on 334 classified points, broken down into the 4 land cover types: 35 water points, 133 urban points, 108 forest points, and 28 barren points. There was only a very few barren points were used because barren points were slightly hard to come by, and we'll look at the end. I think that they make up a very limited amount of the area. Forest points and urban points were oversampled because urban points varied quite a bit in their appearance, and forest points also because they not only include forested areas, but pasture land and farms. Additionally, a temporal persistence rule was added, stating that once an urban area is an urban area, it always stays an urban area. This became very noticeable when looking at later years. You would see that older neighborhoods are starting to become classified as trees because trees had grown up and started to cover the trees, so they looked more like a forest than a neighborhood. All data training was done on the year 2000 map. Once 4 classification maps were then completed, and we can look at those here. This is our classification for 2, with water being blue, urban being gray, forest being green, and barren being tan. The reason urban is gray is it just makes it easier to see on these maps than the red. So we're looking at 2000, so here's our starting point data, and we note something of interest is if you can see here, there's some barren land. Barren lands are generally a precursor to what is going to become urban lands. In 2010, we see growth, and like I said before, those barren lands have now moved, and what was barren has now become urban. And now in 2020, we see very little barren land, so we probably sort of stopped growing to some extent, or at least planned extent. So at least that's what we would assume. But then looking at 2025, we see that things have grown quite a bit, and new barren lands have appeared, indicating that growth is continuing at a continued rate. The next step was to test for accuracy of our model. The model was validated on 64 validation points, 16 per land cover type. Testing was only done using the year 2000 data. The resulting confusion matrix shows that there's only one misclassified point, leading to an overall accuracy of 98%, with forest and water being confused. This may come into play somewhat later, so we will take note of that. The next step was to create an urban progression map. Urban progression map shows what areas became urban between 2000 and 2010, between 2010 and 2020, and then 2020-25 was created. The resulting map is over here. So we have the original urban area in 2000 in gray, and then we've added the 2000 in orange, and then the change from 2010 to 2020 in purple, and finally in 2020 to 2025 in white. I just want to point out a couple interesting things. One is you see a bunch of white up here, and it almost looks like this must not be correct, but this is actually all brand new construction, sort of happening, I would say, quasi part of the villages. We are now going to focus on 2 areas instead of focusing on the whole map. One is this area here on the I-4 corridor, and then down here, kind of southeast of Disney along I-4. So our first area of interest is along I-4 and Highway 28. This is southwest of Disney, which is located up here. We see, at first, most of our building was along the I-4, but then we start to see it building up along this road and along Highway 27. We can't see this because it's outside of our area, but I'm assuming it's also building up. And then once it's built up on the roads, we see this most recent building is kind of filling in the gaps between the major highways. Now looking at along the turnpike, we see that the original growth was sort of east of Claremont, and then it began to fill in between Claremont and Winter Garden, and then the newest growth is mostly to the north and still more infill. Next, I want to look at changes in land cover over time. To determine what land cover types were being replaced by urban areas, a plot of percent cover of each type was calculated. In general, we see that forests or green spaces are being replaced by urban areas. The one exception being in 2025, where lakes begin being replaced by forests and urban areas. This seems a little counterintuitive. I think 2 possible causes for this are 1, maybe lower lake levels, so that lakes are now appearing to be forested because they're covered in plants. Lakes are being misclassified as forests, and as we saw in our accuracy training, that's high. And then finally, probably a combination of both or some other reason not thought of. Finally, in conclusion, the Orlando area has seen significant urban sprawl since 2000. The urban area has grown from 14% to 23% of the total area in 25 years. This means nearly a quarter of that whole area is now urban areas, with large changes from 2000 2010 and 2020 to 2025. And the reason I think growth slowed so much between 2010 and 2020 was probably due to the Great Recession. Um, Two large areas of growth are the area where I-4 intersects with Highway 27, the southwest of the Disney area, and along the turnpike west of Winter Garden along Highway 27. All of these sort of jointly together show large growth on the western side of Orlando, with Highway 27 sort of being a trigger point. I hope everyone found this interesting, and thank you very much.